Guten Morgen, Berlin. How are you doing this morning? I'm Z, and today I'm going to talk about something that I'm really excited about, WebAssembly. WebAssembly is a compiler target for an imaginary CPU that your phones, tablets, laptops, gaming towers, and even your watch can run. It's intended to be a level below JavaScript to allow us to ship code in maintainable languages. And today I'm going to be talking about the fun ways that you can take advantage of this. But first, let's get to the other big word in the topic, Unix. Unix is the sole survivors of the early OS wars from the 70s. It's not really that exciting from a computer science standpoint, other than it's where C became popular, and it uses file and file system API calls to interface with a lot of hardware. So when you're dealing with some source code files, you discover them in this file system in your home directory or somewhere, and you write to them with the file API. If you're dealing with like disks, be they floppy or hard, you discover them in the file system and you manage them with the file API. And this design is, well, all design is rooted in philosophy. And Unix has a core philosophy that all the design decisions stem from, and it's usually quoted as, everything is a file. What does that even mean? What is a file? And wait, who's this Z person? Like those nice people with the microphone said, I'm Z. I'm the person that put IPv6 packets into S3 as a bit, and I work at Tailscale doing developer relations. I'm also the only person I know with the job title of Archmage, and I'm a prolific blogger. I live in Ottawa with my husband. I'm also a philosopher. A little hint, if anyone introduces themselves openly as a philosopher, you should know you're in for some fun. Speaking of fun, I know you got up early for this talk because it sold itself as a WebAssembly talk, but I have to break a little secret with you. This isn't just a WebAssembly talk. This is actually an operating systems talk because most of the difficulties with using WebAssembly in the real world are actually functionally operating systems issues. In this talk, I'm going to start with the Unix philosophy, talk about how it relates to files, and then I'm going to circle back to WebAssembly and some fun hacks, I promise. So going back to where we were with Unix, what does it mean for everything to be a file? Like, what is a file in the first place? So we can really think about files as just kernel objects that you have file handles into. But in a very Unix way, file handles aren't actually opaque values like they are in NT or Darwin. They're just arbitrary integers that just so happen to be indices in an array in kernel memory that point to the underlying kernel goop that make up files. So with these array indices to some core system calls, you can do some basic calls such as, well, actually, now that I think about it, we just spent half an hour going over the history of Go, and let's do a little bit of exercise, get that blood flowing. So how many of you can raise your hands? Yeah, get them up. Get them up? OK. So how many of you, of course, I forgot to hit the button. How many of you have seen one of these 3D printed save icon things in person? If you have, keep your hand up, and if not, just put it down. All right, keep your hand up if you've seen it in person. How about using it? If you haven't used a 3D printed save icon in person, put your hand down. All right. How about one of these audio-only VHS tapes? All right, for those of you with your hands still up, it's probably time for that colonoscopy. Take advantage of that socialized medicine. You can put your hands down now. I don't want to be liable. By the way, for the Gen Z in the crowd that doesn't know what these things are, these are cassette tapes. These are what we used to store music back when there were 9 planets. And so when I say files, let's think about these cassette tapes. At some level, cassette tapes have the same basic usage properties as files. Like, to start, you can read from files, and you can play music from a cassette tape and all that warm analog goodness. You can also write to files and record audio to a cassette tape. Know the term mixtape? That's where it comes from. You can also open files and insert new tapes into the player, and when you're done with them, you can close the files or yeet the sucker out of the tape player. And finally, you can fast forward and rewind on the tape to find the song that you want. You know, just imagine that having to actually locate your songs on the tape. Some wild times. And these 5 basic calls work on your log files, your source code, your hard drives, and more. If you could distill the heart of Unix down to 5 functions, it would probably be open, close, read, write, and seek. This basic model is the core of everything. There's a bunch of other calls that do other things, like set magic properties on files or do non-blocking I/O or whatever. But this basic model gets you so far that you can implement an entire OS around this with even deeper integration to hardware. If you've never heard of something like that, it's called Plan 9. So what about things that don't directly map to files the same way that source code map to files? What about network sockets? Network sockets are the abstraction that Unix and other systems, because they all copied from Unix, use to connect to another computer over a network such as the internet. You can open sockets, you can close sockets, you can read from sockets, you can write to sockets, but does it make sense to be able to seek through a socket? Does that really make it a file? Turns out, at a low level, sockets are files. In Unix, you use the same calls for dealing with network sockets as you do for files. Network sockets are treated like one of these things, a headphone jack to cassette adapter. This is what we used to use back in the day to get our MP3 players, CD players, Game Boys, or smartphones hooked up to the car stereo. This isn't a bit. This is actually something we really used. I did delivery for Domino's, and I used this for my point-to-point nav instructions. We had no options. Bluetooth didn't exist. It was expensive. Cars were cheap. So if these network sockets can be treated like files, like what else is a file? How about processes? Another hallmark of the Unix philosophy is that programs should be filters that allow you to take a lot of data on one end and end up with a little bit of data on the other. So each step just sort of spruces up the input, puts a bell on it, and sends it on its way. So if you can write to a process's input, if you can read from a process's output, does that make it a file? Yes, turns out it's actually 3 files, input, output, and error. Input from the last program becomes, output from the last program becomes input to the next program, and error messages go to the log file or an operator, and all of those pipelines and their shell script abominations that you're afraid to touch and somehow are load-bearing for all of production in several countries. That's the basic flow of data. It's file input, file output, down the chain like an assembly line. Errors might go to an operator or a log such as journald, but really, this is actually a super elegant design, and there's a reason it survived for, 50 years? Yeah. So, you know how I promised that I'd get back to WebAssembly? Here's when. So, Unix is about files, and let's start talking about WebAssembly by talking about what WebAssembly is and more specifically isn't. So at some level, I mentioned before that WebAssembly is a CPU. A CPU can take code and run math and return results. This is, somewhat useful in the same way that a reverse Polish notation calculator is useful, but you need to be able to poke the outside world in order to do things in reality with the internet and file systems and whatnot. So in practice, it's out of the box. It's kind of like this, a microcontroller. Yes, you can use microcontrollers to do lots of fun things, especially when you throw in temperature sensors, CO2 sensors, a GSM shield, or I don't know what else. But microcontrollers can't easily connect to the internet, deal with file systems or storage devices because they don't have an OS. They don't have a base layer that everything builds off of. Pedantically, yes, Arduino exists, there's a bunch of libraries, but you have to basically build all the hardware specifically and configure each library by itself, and there's no real ecosystem cohesion for a lot of that. It makes it difficult, but possible to reuse code from other projects. So if you want to do something like run libraries such as your peer-to-peer VPN engine that you wrote in Go on the browser, you'd need to either do a pile of ridiculous hacks to get things working, or you'd need an operating system. I mean, those hacks do work, and they're all thanks to not a number values, which is another talk. But it turns out that you don't actually need an operating system in the same way that you do with Unix. In WebAssembly, we have WASI for this. WASI is it's the WebAssembly system interface. It's basically a bunch of semantics for how input, output, files, file systems, and some basic network socket operations should be implemented. As far as Go, Rust, Zig, C, C++, Haskell, Char, this is an OS. When you get your compiler to target WASI, they'll make binaries that follow the rules from the WASI specification, and they'll run just about anywhere with a WASI runtime. I wonder what thing that runs on several billion devices, including the SIM cards in all of your cell phones, this reminds you of. No, really. At a high level, we can imagine WASI as functionally similar to the Java or JVM, just without Mr. Ellison's legal dance squad in the way. And you don't have to use Java, because it's a pain in the class. So, circling back on file systems, WASI does have file systems implemented in the spec, but you don't have to use them. As far as WASI goes, it is perfectly legal to not have a file system involved, or at all, the host system or any, and the program is still perfectly able to run. But more critically, to the point I'm trying to build up to, there are a few files that are guaranteed to exist. Standard input, output, and error. And you know what this means? We can circle back to that Unix idea of WebAssembly programs being filters. You can make a WebAssembly program, take input on standard input, do something to it, and emit the result. Just like your pipelines, just without native code. So, as an example, I have an overcomplicated blog engine because of course I do, and one of the overcomplicated things I have in there is my own Markdown dialect because of course I do. And when I rewrote my blog most recently, I rewrote it all in Rust. When I did that, I separated the Markdown parser and all my custom hacks that I've built up over the years into a little command line utility, into a library and a command line utility to play with it in the shell. I compiled that to WebAssembly with WASI. It worked first try. I didn't question it, and I think now I have the library that I use for Markdown as a WebAssembly program that I can distribute around furry avatar templates that Hacker News hates and all. So I'm going to show you some live demo stuff. Let's tempt the demo gods. But to hammer this all in, I'm going to explain what's going on. So I have two programs here. Extra credit if you can tell me after the thing what these are named after. But there's on the right-hand side, there's an echo server that receives connections, takes lines of input, passes them to a WebAssembly program, and then returns the result back to the user. And on the other side, I have a client thing where I have the network implemented as a file system. Yes, this can make sense. And that allows me to connect to this program on the same machine, and everything should thread through. First, I'm going to do it with a standard like echo server thing. It's basically a program like you give it the word foo, it sends out the word foo just to prove that it's working. And then I'm going to switch it over to something a bit more fun. Something else worth mentioning is that I have this confs thing on the left side. And that's whenever you open a file in that file system, it's actually opening a network socket and presenting it to WASI as a file. Because sockets are just files. Why not? So let's show off the power of WebAssembly, and let's tempt the demo gods. So let's go over here. So I have the program on the right. That's the one that is the echo server, and I have the echo client here. And now just to prove that I'm not pre-recording this demo, can someone shout out something for me to type into this left side? I don't know German, so something in English would probably be preferable. Yeah, see? Like, I didn't pre-record that. That lovely person wasn't a plant to make this easier for the pre-recorded demo. That doesn't exist. But You know what? While we're at it, let's do a little bit more. Remember that Markdown library I mentioned? Let's use that. Let's rerun this with the Markdown thing, and let me type this out as one of the little macros in my Markdown parser. Yes, I actually did define my own HTML tags. It's the only thing that made sense at the time. I don't know if it was the best decision, but it works, so. Oh, right, zblog and conv. And bam, there we go. It expanded that little template into a bunch of text, and even though it's getting run by something in Rust, if I press Control / to send sig quit, which will cause the Go runtime to dump its stack, there we go. User Go runtime, proc.go. It's all in Go, even though it's in Rust. Thank God that all worked. I'm going to put all the code on my GitHub repo. I'll have a blog post that explains the demo in a bit more detail, because there's some subtle magic here that's probably lost in the glossing over. But so I took a Rust program, I embedded it into a Go program, and I call this technique crab toe espionage. It lets you use the property of Unix programs being filters to recreate another fundamental of computer science, functions. This is how you Rustaceans in the crowd, I know you exist, I invited one of you, can sneak Rust into prod without having to make sacrifices to the linker gods, setting up compilers, and we're running out of goats. We can't keep sacrificing them to the linker gods. So when you build your program into WebAssembly, you can commit the .wasm bytes and then embed it with Go embed, and then you can still build everything on a Mac, cross-compiling to Linux, or Plan 9, cross-compiling to Windows, or Temple OS. God forbid you run Go on Temple OS. So the core of how all of that works is thanks to this lovely library for Go called WASI. It is basically a WebAssembly VM and all the hooks for WASI implemented for you, so you can override it with your own file system logic, your own standard input, your own standard output, and other fun things. So if you want to do this in your own code base, I don't know if you should, but if you want to do it, here's how you would do it. First, you find the subset of the library that you want to run in your Go program. You extract it into a little command line program so that you can test it, make sure that you have the flags going to the right thing. Flags and arguments, they're there for a reason. Use them. Then you build that to WASI, and you'll probably have to fix a couple things until it works. WASI doesn't support outgoing sockets yet. It's kind of a problem. I wish it wasn't that way, but it's the world we live in. Usually things will work, but you're going to have to draw the rest of the O here. Then you import WASI into your program. You set up everything using the embed directive, create a runtime, precompile the code, and you're off to the races. And then you can make a wrapper function that lets you go from input to output, and voila, you have a monstrosity like this. And this is how I snuck Rust into prod at work. Nobody is the wiser. This is recorded. I just gave it away. Oops. Sorry, Tailscale. I had no choice. Mastodon HTML is really weird. The Go HTML parser was so much weirder. Besides just, massaging HTML into Slack-flavored Markdown, you can use this basic technique for more things, like C libraries. Normally, when you have a C library and you want to use it with CGO, it is a pain unless you have one target, and that target is Linux, and you have everything managed with your package manager, and you don't question why everything works. With WebAssembly, though, you can put a C library into WebAssembly and then expose all the hooks, and it doesn't matter that it's written in C or C++. It'll just work. And in the case of this regular expressions package on GitHub, it's faster than the standard library. There's not even that many optimizations for WebAssembly yet. There's hardly vector stuff. It's nuts. And you don't need a C compiler. You don't need to cross-compile GCC. You don't need to have like 40 copies of GCC because it can't do more than one target because Stallman can't read his email. And it just works. It's magic, but no spell slots. So while we're on this, let's take this to their logical conclusions. Giving this, where could you do some like hilariously cursed stuff? What about plugins? I mean, there's plenty of reasons why customers would want to have plugins running on your servers to respond to arbitrary events. And as the person running those servers, there's plenty of reason to fear every single word of that last sentence. So if WebAssembly lets us isolate things, we can control how the file system works. We can put well-formed events on standard input. We can receive well-formed events on standard output. And there's exit codes in case anything blows up and an error log. How would you get the rest of stuff in the rest of the application state into the WebAssembly modules? How about the file system? If you can define your own file system logic, then you can just expose anything. If you've ever used Plan 9, this is basically how the Acme editor works. All of the internal state is exposed as a file system so that you can write your plugins in shell script, Go, C, Java, or whatever else you use on Plan 9 these days. It's just a file system. It's just files. Why should it be hard? So to wrap this all up, Unix, files. Whether it's source code, hard drives, or sockets, it's all files. Like anything around a standards body, even files themselves are lies, and anything can be a file if it lies truthfully enough. Understanding that everything is founded on these lies and taking advantage of that can free you from the expectations of having to be totally consistent with everything. This lets you run things wherever you want without having to have a C compiler for Win32 handy or more goat sacrifices we're really running out. Because if you control the lies, you control the truth of what users see. When you free yourself from the idea of having to stay consistent with the past, you can do whatever you want, like exposing the network as a file system. So how could you use this in your projects to do like hilariously cursed things that could end up on this stage? Ball's in your court. With all that said, here's a giant list of everybody that's helped me through this talk, the research, the sneaking it into production, and God knows what else. Thank you so much to all these people. And with that, I've been Z. Thank you so much for coming out to Berlin. I'll be wandering around if you have any questions. But if I missed your questions, please send your questions to crabtoeespionage@zserve.us. I will reply, really. I have an example code in the conferences folder of my GitHub repo. I'll post something on my blog and my Twitter about it. Otherwise, stay hydrated, enjoy the conference, and be well.